Okay, the notes that you just picked up from the back table are going to go in your composition, where you have your by the numbers, your hall passes. Yesterday we started your table of contents. So the first lesson is the real number system. We're never going to start notes on the back of the page, so leave on the back of the contents page, leave that blank because you'll need that room later for more table of content and stuff. So on the next clean page that's over here on the right, you need to put a big number 1 up here in the corner. You need to turn it sideways like this. I would zoom out more, but as far as my little stand goes, so the first one that you're going to glue down, that should already be cut out, is the white one, the biggest one, that says real numbers. All of the numbers that we work with in the 8th grade are classified as real numbers. And that's broken down into 2 sets, the rational numbers and the irrational numbers. I'm going to talk more about those in detail in a second because it's kind of easier for me to start with the little group and work my way out. So next I want you to glue down the yellow page that says integers. You worked with integers a whole lot in the 7th grade, was adding, subtracting, multiplying, and dividing integers, all those rules. The next set that you're going to glue down is orange. It says whole numbers. You've worked with whole numbers for a long time, ever since you were in elementary. The last one you're gluing down here is the pink one. This group has 2 names, so it can be called the counting numbers or the natural numbers. And the easiest way for me to explain them is whenever you just have to think of whenever you started kindergarten. You started counting with the numbers 1, 2, 3, and so on. So the very smallest set of numbers that we work with is the natural numbers, and it's where you naturally start counting 1, 2, 3, 4. The whole numbers it includes all of these, but there's just one more. Some of you might remember that it includes the number 0, and then it goes 1, 2, 3, ... Make sure you're putting your numbers on your notes. The next set, the integers that you worked with last year, includes all of the counting numbers and all the whole numbers. So basically it's going to look like these numbers, and it includes all of their opposites, or the negative version of those numbers. So we can say -3, -2, -1, 0, 1, 2, ... Those are all of your integers. Notice that in this set and in these, we never put a fraction. We never put a decimal number like 1.5. So no fractions or decimals are ever going to be called a natural number, a whole number, or an integer. They are introduced here in the rational numbers. So the rational numbers includes all of this, because these bubbles are inside this part of the page. It includes all of these, and decimals like 7500ths, or a decimal like 5/10. You're probably thinking of some you could add. It also includes decimals that repeat. A really common one, you know, the fraction 1/3. It is the decimal of 0.3 repeating. The fraction 2/3 is the decimal of 0.6 repeating. Okay, so rational numbers have decimals that terminate, like these, they stop. And the rational numbers has decimals that repeat. They go on and on and on, and they repeat either a pattern or they just repeat the same number. They also include fractions. So this is the fraction of 1/2, 3/4, 1/3, and 2/3. Okay, the only set of numbers that we have left to talk about is, if I can get my iPad to look at it, the irrational numbers. So the irrational numbers cannot be anything that's over here. So my natural counting numbers, the number 0, positive and negative numbers, fractions, or decimals that terminate or decimals that repeat. So you might be thinking, what other number is there? Well, we're going to have numbers that whenever they're written as decimals, they never repeat a pattern and they never end. Can you think of one? Let's pretend like I'm there. I would call on somebody. You back there. Pi. This is the most popular one, because if you type in pi on your calculator, which is in blue, so we had to hit the blue key first. It's over here under clear, and I hit enter. Okay, it kind of looks like it stops, but my calculator just stops at a certain point. But if I look at these, it never repeats, and numbers don't really go this far and then just randomly stop. They just keep on going. So this is an irrational number because it's like a bunch of randomness that never repeats, and we know pi never ends. Another good example would be the square root of 6. The square root of, let's say, 12. So there are perfect square roots, like if you wanted the square root of 4, well, that's just 2. So that's not irrational. But the ones that are close to the perfect ones, they are irrational, like these. You can always type it in and see what it does.